Okay, so let us discuss with the remaining problems. Excluding errors, we have already done with many problems of chapter 1, Maharashtra State Board, textbook physics, class 11. So here I am going to read this problem. B is equals to 80 plus B, this is little bit invisible. Yeah, B upon T plus C plus V naught is a dimensionally valued equation. Obtain the dimensional formula for A, B and C where V is velocity, T is time and V naught is initial velocity. So let us solve it. The given equation V is equals to 80 plus B upon T plus C plus V naught. It is given in the problem that the equation is dimensionally valid. It means it is dimensionally correct equation where the symbols have their usual meaning. V is equals to velocity, small t is the time, then V naught is also a velocity, initial velocity, and this is final velocity. We are asked to find the dimensional formula for A, B and C. So let us do it. Generally what happens is that the quantities which are having same dimensions, those physical quantities only will be added. For example, 5 meter per second velocity, 5 meter per second velocity, another 6 meter per second velocity. Two objects, they are moving with these two different velocities. We are asked to find their resultant. So how you will find their resultant? So resultant will be it can be calculated by addition of these two. Therefore, it will be calculated as 5 meter per second plus 6 meter per second. So how much it will be? 5 plus 6 meter per second as it is. It will be taken out. So that is 11 meter per second. It means that only magnitudes will be added. Their units will not be added. In the same manner, one more example I will take to explain it. One velocity is given, V is equals to 2 meter per second, and we are given force, F is equals to, let us say, 2 Newton. Can we able to add these two quantities? So answer to this question is definitely we cannot find their resultant because this is a different quantity, this is different quantity. So two different physical quantities, the resultant cannot be calculated. It means that they cannot be either added or subtracted. Therefore, from this equation as it is given in the example that this given equation 1, which is dimensionally valid equation, dimensionally correct equation, it means that dimension of, as on the LHS side there is velocity, it means that each and every term of this equation, RHS of this equation, AT, B upon T plus C and V naught, it is having dimensions of velocity. So to find the dimensions, we are going to take into consideration this term, the dimensions of velocity, dimensions of LHS. So velocity dimensions, I will write it as velocity unit L1 meter per second, so it is L1 T raised to minus 1. Therefore, let us equate one by one the dimensions of LHS equal to dimensions of AT. term AT. So what are the dimensions of LHS? L1 t raised to minus 1. RHS dimensions, A, t is the time, so it is t raised to 1. So A will be L raised to 1, t raised to minus 1. This t is shifting to the other side, it will be divided. So it will be t raised to 1. On simplifying, it will be L raised to 1, t raised to minus 1. This plus 1 shifting to the numerator becomes minus 1. So the dimensions of A are L1 t raised to minus 1 minus 1 minus 2. Let's do it for the second term. That is dimensions of velocity is equals to dimensions of term v upon t plus c. Again here in this t plus c, as t has dimensions of time, the dimensions of c that must be same as that of this dimensions of time, then only these two are added. Therefore, to write the dimensions of c, it should be same as that of the dimensions of time, that is t raised to 1. Now, to find these dimensions of b, let us again take into consideration this equation. We got c, dimensions of c. Therefore, it will be L1 t raised to minus 1 LHS equals to dimensions of b upon t plus t. You cannot write it as 2t because we are writing dimension, just like 2 meter per second plus 5 meter per second, that will be 7 meter per second. So units or dimensions that cannot be added or subtracted. So that will be written only once for a given addition or subtraction. Therefore, it will be written as t raised to 1. Ultimately, the addition of these two, that comes out to be time term only, and the time has dimensions t raised to 1. Therefore, it will be t raised to 1. Therefore, b is equals to L raised to 1, t raised to minus 1. This will be multiplied here, so it will be t raised to 1. Therefore, dimensions of b will be L1, this t raised to minus 1, t raised to plus 1 get cancelled, so it is L1. So, these are the dimensions of C. Here it is B, and already we have done with the A. So, this is example number 10. Now, let us discuss the last example which is based on significant figures. Here, significant figures, it has some rules. So, while explaining the example, while explaining this problem based on significant figures, I will explain the rules also. It has certain rules, and based on that, we are going to find it. Okay, so let us discuss one by one. First, let me read the problem. Write down the number of significant figures in the following: 0.003 meter square, 0.1250 gram centimeter square, 6.4 into 10 raised to 6 meter, 1.6 into 10 raised to minus 19 coulomb, and 9.1 into 10 raised to minus 31 kg. We are asked to find the significant figures, and here are the rules of finding significant figures. Let us discuss one by one. First example, it is 0.003 meter square. Area is given. We are asked to find the dimensions. Okay, so the zeros on the RHS of decimal point and on the LHS of first non-zero number, they are not significant. So it is given in one of the rules here. Look at this, rule number 3. They given one example. If the number is less than 1, the 0 or zeros on the right of the decimal point and to the left of the first non-zero digit are significant. Therefore, 0.001405, the underlined zeros are not significant. It means that to the right side of this decimal point, these zeros, and if the number is less than 1, then in that case, and to the left hand side of first non-zero digit, these zeros are not significant. It means that the non-zero number which is included in this figure, it is significant. Therefore, significant figure, I think better make a column, so it will be easy to understand. Some problem is there, it's not responding. Let me write it, heading, number, significant figures. In the given decimal, in the given number, all non-zero numbers, they are significant. So, as per the rule, 0.003, there is one significant figure. What about these zeros? The zeros which are on the right side of decimal and to the first non-zero, left side of first non-zero digit, they are not significant. Therefore, significant, that is non-zero number present here, it is 1. So, significant figures are 1. Next example, it is given that 0.1250. In this case, if the number is less than 1 and the zeros, if they are coming after the decimal point, after the non-zero digit, after the decimal point and after the non-zero digit, they are considered to be significant. Why they are considered to be significant? Why this zero is taken into consideration as a significant figure? Because this number is indicating that you can measure the least count of given whatever may be the measuring instrument, its least count is 0.0001. It means that you can measure, that particular measurement can be done up to 4 significant figures. The correct measurement can be done. That's why this 0 which is coming after the non-zero, after the decimal point and after non-zero digit, they are taken as a significant figures. Therefore, and of course non-zero numbers, they are significant. Therefore, in this significant figures are 4. Okay. Next question, next example, it is 6.4 into 10 raised to 6 meter. It is the radius of Earth. Now, in this case, what to do with it? That is, there is a fashion to express this number in terms of power of, either it is a positive power or negative power of 10. Then in that case, the non-zero digits are, they are taken as a significant. So here 6 and 4, they are significant figures. So in this case, this is the significant figure and order of magnitude of this number is 6. Another, if the number is very less or very big, then in that case we express them in terms of power of 10. So then it will be easy to find that number, the significant figures of that number. Okay, so it is 1.6 into 10 raised to minus 19 coulomb. This is charge of electron. So here in this case 1 and 6 they are non-zero numbers and their significant figures are 2. Another example, it is the mass of electron, it is 9.1 into 10 raised to minus 31 kg. So in this case again the significant, the non-zero digits, they are the significant. So in this manner there we can find the significant figure. For example, sometimes you all are given the number which is in terms of a very big number, it is given. For example 12500, just like which is taken here, 12500 centimeter. If it is given and we are asked how many significant zeros are there. If number is greater than 1, the zeros which are coming after the non-zero digit, they are not significant. Therefore, in this case, non-zero digits which are present here are 3. Therefore, it has 3 significant figures. Clear? Another, if we are given one more example, just like which is taken here. If we consider this example as the zeros on the right hand side of the last non-zero number are significant, but for this the number must be written with a decimal point. For example 1.500 or 0.01500. We have both 4 significant figures. Okay, so we will first of all explain this example 1.500. In this case, rule number 4, I was reading this. In this case, these zeros, they are taken into consideration as a significant. Why they are taken as a consideration as a significant figure? Because they tell us about information about the least count of that particular measurement. That is up to how many decimal, up to how many digits after the decimal point the measurement is done accurately. These zeros, though they are coming after 5 and they don't contribute much in the measurement, but they give us very important information about the measurement, accurate measurement. So these zeros are significant. Therefore, in this case, 4 is the significant figure. Another example which they have taken 0.01500. In this example, again, the zeros which are to the right side of decimal point and to the left side of first non-zero digit, they are not significant. But as per this rule, the zeros which are after, if the number is less than, if the number is expressed in terms of decimal, these zeros take into consideration because they play very important role in sharing the information about how accurately the measurement is done or by which instrument the measurement is done, which shares us important information about that. Therefore, they are significant. Therefore, non-zero digit 1, 5, then these 2 zeros. So, significant figure in this number also are